Hello and welcome. In this video, we are discussing inverse Z transform. We are solving one example based on method partial fraction method. Inverse Z transform. Question is find inverse Z transform by partial fraction method for causal, anti-causal and stable system. Or same question can become as a find inverse Z transform for all possible ROCs, or same question can be expressed as a find inverse Z transform for ROC first case mod Z greater than 1 half, mod Z less than 1 by 3 and mod Z greater than 1 by 3 less than 1 half, and this is the x of Z is given. Always remember there are some steps to find the inverse Z transform. First case or first step. First check whether the power of all the Z are positive. If not, we can make it positive by dividing both the numerator and denominator polynomial with the maximum negative power of denominator Z. Here all the powers of Z are positive, so no worries. We'll go for the next step. In case of partial fraction for Z transform, always we are applying partial fraction for x of Z upon Z. That's why first step is divide both the sides of this by Z. So Z x of Z upon Z is equal to 1 upon Z and this x of Z. So we divided both the side by Z. Now here Z can be we can take common and it will get cancelled. So Z is common here and it will get cancelled. So our x of Z upon Z is Z plus 2 divided by Z square minus 5 by 6Z plus 1 by 6. Now this is our x of Z upon Z. At this stage, second step is before applying partial fraction, we have to check whether this x of Z upon Z is in a proper form or not for applying partial fraction. And the proper form is whether the degree of numerator polynomial is less than the degree of denominator polynomial or not. So here highest degree is 1 and here highest degree is 2. So degree of numerator polynomial is less than denominator polynomial. So we can apply here partial fraction. If it is not, you have to perform long division and then apply the partial fraction. Now this is the condition to check the proper form. Here we can apply partial fraction. To apply partial fraction, we will first take roots of denominator polynomial. 1 by 2 and 1 by 3 are roots of denominator polynomial. So this denominator polynomial we can express as a Z minus 1 half and Z minus 1 by 3. Now apply partial fraction and divide the roots a upon Z minus 1 half plus b upon Z minus 1 by 3. Let's find the value of a and b. A is in the denominator Z minus 1 half. So multiply x of Z upon Z by Z minus 1 half and put Z is equal to 1 by 2. So Z minus 1 half and this whole x of Z upon Z is Z plus 2, Z minus 1 half, Z by minus 1 by 3. So this will get cancelled and put the value Z is equal to 1 half here and the answer is 15. So A is 15 here. Similarly B, instead of Z minus 1 half, what we will do? Z minus 1 by 3 and Z is equal to 1 by 3. Z is equal to 1 by 3. Put Z upon Z minus Z x of Z upon Z here and you will get this x of Z upon Z. This Z minus 1 by 3 will get cancelled and put Z is equal to here 1 by 3 and you will get minus 14. So A is 15 and B is minus 14. Let's put it A and B. Now remember for inverse Z transform, we have taken partial fraction of x of Z upon Z because in case of inverse Z transform, we have the formula for Z upon Z minus A. That's why we need this Z. So this Z at this stage you can take to the RHS, right side. So this Z we are shifting to the RHS and your x of Z becomes 15 Z upon Z minus 1 half plus minus 14 Z upon Z minus 1 half. And here we can apply inverse Z transform. Now if you check the question, inverse Z transform we want for different conditions of ROC or for all possible ROCs or for causal, anti-causal and stable system. So first we will see for causal system, or we can say for the ROC condition mod Z greater than 1 half. For causal system, we have the formula. In case of where you are getting Z upon Z minus n, we can take the inverse as a raised to n u of n, and the condition of ROC is mod Z greater than a. Now check the first form, Z upon Z minus a. A is here 1 half. So here for causal, inverse is a raised to n, means 1 half raised to n u of n, and ROC will be mod Z greater than a is 1 half. So like this, for here also minus 14 as it is, Z upon Z minus a is 1 by 3 here. So 1 by 3 raised to n u of n, and in this case ROC will be mod Z greater than 1 by 3. Now here two ROCs you are getting. For this one, mod Z greater than a is 1 half, and here mod Z greater than a is 1 by 3. So first case ROC is mod Z greater than 1 by 2, means this is the circle whose radius is 1 half, and all the values of Z or entire Z region which is greater than this 1 half is your ROC. In the second case, what is the ROC? Mod Z greater than 1 by 3, means we have to take a circle of radius 1 by 3 and all the values of Z which are greater than 1 by 3 is our ROC in the second case. But our sequence is combination of both. So ROC should be combination of both. The intersection, the common region of both the ROC is the ROC of your entire X of n. So for that we'll check what is the common portion for both the ROCs, or what is the intersection of both the ROC. Let's see. So here you can check combined portion is for both mod Z greater than 1 by 3 and mod Z greater than 1 half. Common portion is or intersection region is mod Z greater than 1 half. This inside region is not for mod Z greater than 1 half. It is only for mod Z greater than 1 by 3. So common ROC for both the sequences mod Z greater than 1 half. So the ROC of combined sequence is common portion, that is mod Z greater than 1 half. So this is the first case. In the question it can be find inverse for causal system or find inverse for ROC condition mod Z greater than 1 half. Now the second case. So this is our combined ROC mod Z greater than 1 half. Second case for anti-causal system. Same X of Z is there. For anti-causal, we are using the formula Z upon Z minus A. Z upon Z minus A, we are taking inverse as a minus A raised to n u of minus n minus 1. It is for anti-causal. Why we are saying this? Because u of minus n minus 1 exists only for n less than 0, for the negative values of n. That means it is left-sided sequence. That means it is anti-causal. And ROC is mod Z less than A. In the previous case, for Z upon Z minus A, when we are taking inverse as a raised to n u of n, ROC is mod Z greater than A. Here ROC is less than A. So for Z upon Z minus 1 half, Z minus A is here 1 half. So ROC or inverse we are taking minus 15 as it is minus A raised to n u of minus n minus 1. Now here minus 14 and inverse is minus 1 half raised to 1 by 3 raised to n. So this minus and minus 14 become plus 1 by 3 raised to n u of minus n minus 1. So in the first case, ROC is mod Z less than A is 1 half. In the second case, ROC is mod Z less than 1 by 3. Let's see. First case, ROC is mod Z less than 1 by 2, means interior of the circle whose radius is 1 by 2. And in the second case, ROC is mod Z less than 1 by 3. 1 by 3 means interior of the circle whose radius is 1 by 3. But our sequence x of n is the combination of this and this sequence. So our ROC should be combination of both, intersection portion of both, or combined region of both the ROC. Let's see. If you check here, what is the intersection portion? What is the common portion of both the ROCs? Mod z less than 1 by 3. That's why the ROC of our combined sequence is mod z less than 1 by 3, which is the intersection portion of both the ROCs. So our combined ROC is mod z less than 1 by 3. So this is for anti-causal system. Now in the last condition, we can take combination of both causal and anti-causal. So we need both the formulas. Here ROC is mod z greater than 1 by 3 less than 1 half. The greater than lowest value and less than highest value. Let's see. When we want mod z greater than 1 by 3, which formula we'll use? Mod z greater than 1 by 3 means the formula for causal. For z upon z minus a, we'll take inverse a raised to n u of n. So here we want mod z greater than 1 by 3 means this z upon z minus 1 by 3. For this, we'll apply this formula. And for the second case, mod z less than 1 by 3. Check here ROC mod z less than a. A is here 1 by 2. 1 by 2 means this. So for this z upon z minus a is 1 by 2. We want mod z less than a. So we'll use minus 1 half raised to n u of minus n minus 1. For mod z greater than 1 by 3, we'll use 1 by 3 raised to n u of n. So here minus, here 15 as it is, mod z less than 1 by 2. So minus a raised to n, 1 by 2 raised to n, u of minus n minus 1 according to this case, mod z less than 1 by 2. And for mod z greater than 1 by 3, we'll use mod z greater than 1 by 3, that is 1 by 3 raised to n u of n, and this minus 14 as it is. Let's check the ROC. For first case, ROC is mod z less than 1 by 2, interior of the circle whose radius is 1 by 2. And here ROC is mod z greater than 1 by 3. That is the exterior portion of the circle whose radius is 1 by 3. But here our sequence is combination of both. So ROC should be intersection region of the both the ROCs. Let's check. Now this squared portion is the intersection region, means mod z greater than 1 by 3 and mod z less than 1 by 3. That is this ring. So this is the ROC, mod z greater than 1 by 3, mod z less than 1 by 2. So in this case, we have solved example of inverse Z transform for all the possible ROC. In the first case, we are taking the inverse by applying this first formula a raised to n u of n for z upon z minus a. So in that case, our sequence is causal. Both the values are a raised to n u of n, that means right-sided sequence. In second case, anti-causal, we are using this second formula z upon z minus a. So inverse is minus a raised to n u of minus n minus 1. This indicate your sequence is left-sided sequence, that is for the negative values of n. So it is anti-causal. In third case, we are using both the formulas. For the lowest value, mod z greater than lowest value, and for highest value of root, mod z less than that highest value. So ROC will be ring between greater than lowest value and less than the highest value. One more question is there, whether the system is stable or not. If your ROC includes unit circle, your system is stable. So only in the first case, your ROC include unit circle, mod z greater than 1 half. So the first case system is causal also and stable also. Other systems are not stable because it doesn't include the unit circle. Unit circle means the circle whose radius is 1. So here by default, here all the ROC includes mod z greater than 1 half, means it includes unit circle. Thank you.